Good day everyone, let us continue our discussion with the third unit, which is the basic knowledge and skills in electronics. What is electronics? Electronics is a branch of technology that deals with many applications. Audio electronics, video electronics, digital, medical, up to weapons and banking are covered by influence of electronics. There are quite a number of components used in application of electronics. This course introduces you to the different tools and equipment and basic components of electronics, such as resistor, diodes, transistors, and capacitor. In addition, it covers the basic operation and some common application of such components. Electronic hand tools and equipment. Assembling electronics project and making it work is a good start in helping one to learn troubleshooting methods as well as becoming familiar with your tools. Test equipment, electronic schematics, and component color codes. It's hard to do a good job for electronics construction unless proper electronic tools and knowledge of using them are adequate. Some of the basic tools that should prove useful. First on the list is the screwdriver. It is designed to insert and tighten or to loosen and remove screws. A screwdriver comprises a head or tip which engages with a screw, mechanism to apply force by rotating the tip, and some way to position and support the screwdriver, the tip of which is shaped to fit a particular type of screw. Screwdrivers have two main types. First is the slotted screwdriver. It is used to drive or fasten negative slotted screws. It is a tool used to apply torque to screws using a flat tip. Torque is the pressure applied when a device is turned clockwise or counterclockwise into place. The next one is a Phillips screwdriver. It is used to drive or fasten positive slotted screws. It is a screwdriver that could take greater torque and could provide tighter fastenings. Soldering iron. A soldering iron is composed of a heated metal tip and an isolated handle. For electrical work, wires are usually soldered to printed circuit boards, other wires, or small terminals. A low power iron, 20 to 30 watts, is suitable for this work. Soldering tool stand, a place where the soldering iron is placed during usage. This will keep the soldering iron away from flammable materials. The stand often comes with a sponge used in cleaning the tip of the soldering iron. The soldering tool, used in removing soldered wires and components of printed circuit boards for troubleshooting and repair purposes. Here is how soldering iron is done.
Alright, what is soldering? It's a really good question. Soldering is a process of joining different types of metals. And in the case of electronics, we're really interested in joining copper to, say, a printed circuit board. So we have solder, which is an alloy, usually tin and lead. In order to solder, you need to melt the metal by adding heat. And so we use an iron, which has a pointed tip like this. And this one is connected to a controller, which allows us to adjust the temperature. And it's important to have the temperature within a certain range. In this case, we're going to look for temperatures right around 600 degrees Fahrenheit, which is above the melting point of the solder. Next, we have a soldering sponge, which is used to clean the tip. And you can see it producing a little bit of steam as it boils the water. And you also hear that sound. So it's all built into the soldering iron stand. Nice, convenient piece of equipment. Since I'm right-handed, I'm going to be holding the solder in my left and the iron in my right. And just to show you as an example, we're going to put some solder on one of these printed circuit pads. To begin, we'll start by cleaning the tip. So we have a nice shiny tip. Place the tip on the part that you want to heat. Give it a few seconds to warm the part, and then feed in some solder. And there it is. Soldering electronics is about joining components, individual resistors and capacitors and other things to a printed circuit board. And solder is necessary to make, for a couple of reasons. One, we need to make an electrical connection between the part and the circuitry on the board. And we also need to make a mechanical connection so that the part doesn't move. So we need this electrical and mechanical bond. Solder is what provides that. So it's important to know about this procedure so that we can make a proper bond that's going to last a long time.
Next is splicing tools. These tools are primarily used to hold, bend, cut, and strip the lid of electronic components such as long nose, side cutter, and wire stripper. Long nose. It is used for holding, bending, and stretching the lid of electronic component or connecting wires. Side cutter. Wire cutting pliers, though they are not used to grab or turn anything but are used to cut wire. Wire stripper. It is a pair of opposing blades, much like scissors or wire cutters. Aside from hand tools, other types of equipment are also needed for some accurate and quality output. 3 of the most used equipment are presented here for you to be familiar with their uses and the proper way of maintaining them, such as oscilloscope, signal generator, and volt-ohm millimeter. An oscilloscope, commonly abbreviated CRO for cathode ray oscilloscope or scope, is a piece of electronics test equipment that allows signal voltage to be viewed, usually as two-dimensional graph of one or more electrical potential differences, vertical axis plotted as a function of time, or for some other voltage, horizontal axis. The primary function of an oscilloscope is to measure voltage waves. Scan the quick response code to learn more on the use of oscilloscope in electronics. Signal generator is a device which produces simple waveforms. It is an electrical test instrument that delivers an accurately calibrated signal at frequencies from the audio to microwave ranges. It is valuable in the development and testing of electronic hardware. Scan the quick response code to learn more on the use of signal generator in electronics. Next is volt-ohm millimeter. A multimeter is a measuring instrument that can measure multiple electrical properties. A typical multimeter can measure voltage, resistance, and current, in which case it is also known as volt-millimeter. It is useful for testing appliances because it is used while the power is turned off, so there's no danger of electrical shock. It provides more precise information than the continuity tester and therefore is preferable for testing many components. Scan the quick response code to learn more on the use of volt-ohm millimeter in electronics. Another important electronic component is a resistor. Resistor is a passive electrical component that creates resistance in the flow of electric current. In almost all electrical networks and electronic circuits, they can be found. The resistance is measured in ohms. An ohm is the resistance that occurs when the current of 1 ampere passes through a resistor with a 1 volt drop across its terminals. Resistors are used for many purposes. A few examples including limiting electrical current, voltage division, heat generation, matching and loading circuits, gain control, and setting time constants. Resistor color coding. Resistor color coding uses color bands to easily identify a resistor resistive value and its percentage tolerance. This video explains how to use the resistor color code chart to determine the value of the resistance of a resistor in an electrical circuit. It explains how to use the chart to find the first two digits, the multiplier and the tolerance level, which can be used to determine the range in which the true resistance lies in.
In this video, we're going to talk about how to use the resistor color code in order to determine the value of a resistor. So the first color, reading it from left to right, is for the first digit. So the first color is red. Well, let's actually use the color red. The second color is yellow. The third color, let's just say it's orange. The last color is for the tolerance. It's usually either gold, silver, or no color. So let's say this is gold. I'm going to put a G for gold. So what you need to do is, when you have the first color, which is red, look for the number in a table. So red corresponds to 2. That's the first digit. The second color, yellow, correlates to the second digit. And based on the table, yellow is associated with 4. So you can have 24 or 24. O, or orange, is 3, but the third number is the multiplier. The first two letters corresponds to the first two digits. The third letter corresponds to the multiplier, which is 10 to the third. So this is 24 times 10 to the third. And the last color is the tolerance, which is usually gold, silver, or no color. So since we have gold, the tolerance is 5%. So it's going to be plus or minus 5%. Now what is 10 to the third? 10 to the third is basically 10 times 10 times 10, 3 times, or just 1,000. So 24 times 1,000 is 24,000. So that's the value of the resistance. It's 24,000 ohms. Now because this number is so large, let's convert it to kilo ohms. To convert it to kilo ohms, just divide by 1,000. 1 kilo ohm is equal to 1,000 ohms. So therefore, this is about 24 kilo ohms, plus or minus 5%. Now let's go ahead and calculate the range. So what we want to do is find out what 5% of the resistance is equal to. So right now we have 24 kilo ohms plus or minus 5%. So let's multiply 24K by 0.05, which is going to be 5% of it. And that's about 1.2 kilo ohms. So the actual resistance can vary between 1.2 kilo ohms from 24 kilo ohms. So it could be 24 minus 1.2. So it can be 22.8 kilo ohms on the low side, or it can be 24 plus 1.2, which will be 25.2 kilo ohms. So based on this information, the resistance is about 24 kilo ohms, but the actual value can be anywhere between 22.8 and 25.2. And so you should always check the tolerance level to see where the true resistance may lie. Now it's your turn. Go ahead and calculate the value of this resistor, determine the tolerance level, and also the range in which the true resistance may lie. So the first color is green, the second is blue, the third is red, and the fourth, which is the tolerance, is silver. So the first color is associated with the first digit. Green has a number of 5. So the first digit is 5. Next we have blue, which is associated with 6. The second color is for the second digit. And then we're going to multiply. Now, the third color is for the multiplier. And since we have red, the multiplier for red is 10 squared. So we're going to multiply by 10 to the second power. And then the last color is associated with the tolerance. For silver, the tolerance is 10%. So it's going to be plus or minus 10%. 10 squared, or 10 times 10, is 100. So 56 times 100 is 5600. So that's the resistance. It's 5600 ohms, plus or minus 10%. Now let's calculate 10% of 5600. So 5600 times 10%, which is 0.10. To convert a percentage to a decimal, you can divide by 100 or move the decimal point 2 units to the left. 5600 times 0.10 is 560. So basically, we need to add or subtract by 560. 5600 plus 560 is 6160, and 5600 minus 560, that's 5040. So the actual resistance could be anywhere between 5040 ohms and 6160 ohms, with the average value being around 5600. So this is the resistance, and this is the range in which the actual resistance can be. Here's another one you could try. Go ahead and calculate the resistance using the resistor color code and determine the tolerance and also the range in which the true resistance can lie. So feel free to pause the video and see what the solution is going to be. Unpause it whenever you're ready. So the first color is yellow, the second one is purple or violet, the third one is green, and the last one has no color. So the first color is associated with the first digit. So yellow corresponds to 4. The second color is for the second digit. Violet corresponds to 7. The third color is for the multiplier. Green has a multiplier of 10 to the 5th. And the last one is for the tolerance level. For no color, the tolerance is very high, it's 20%. That is plus or minus 20%. But let's deal with the percentage later. What's 47 times 10 to the 5? 10 to the 5 is basically 100,000. It's a 1 with 5 zeros. And if you multiply 47 by 100,000, that's going to be 4.7 million. Or 4,700,000. So that is the resistance level in ohms, which if you put it back in scientific notation, by moving the decimal 6 units to the left, this is equivalent to 4.7 times 10 to the 6 ohms. Now, 10 to the 6 is basically a million, which represents mega. Mega is equal to 10 to the 6, so this, you can write it as 4.7 mega ohms. Anytime you have a value above 1,000, it's common to write it in terms of kilo ohms. If it's above a million, you want to use mega ohms. So now, what is 20% of 4.7? So if we multiply 4.7 by 0.20, don't forget to divide 20 by 100, this is going to give us 0.94. So the resistance could be anywhere between 4.7 mega ohms plus or minus 0.94 mega ohms. The unit has to be the same. So the lowest value is going to be 4.7 minus 0.94, which is 3.76 mega ohms. And the highest value is 4.7 plus 0.94, which is 5.64 mega ohms. So the average resistance for this particular resistor is about 4.7 mega ohms. The tolerance level is 20%, and the range is between 3.76 and 5.64. So this resistor can have any value in this range, but most likely it's going to be around 4.7 mega ohms.
Next is capacitor. It is a component which has the ability or capacity to store energy in the form of electrical charge, producing a potential difference or static voltage across its planes, much like a small rechargeable battery. One of the most common applications of capacitor is to smooth out peaks when converting AC to DC. Scan the quick response code to learn more on how capacitors work, where capacitors are used, why capacitors are used, and the different types. And we'll look at capacitors in power factor and full bridge rectifier to convert AC to DC. Next is the diodes. It allows the current to flow in only one direction. We use diodes to control the direction of current flow in a circuit. That is useful, for example, to protect our circuit if the power supply was connected back to front. The diode can block the current and keep our components safe. Scan the quick response code to learn more on how diodes work, where diodes are used, why diodes are used, and its different types. And lastly is the transistor. It's a semiconductor device used to amplify or switch electronic signals and electrical power. Transistors is one of the basic building blocks of modern electronics. It is composed of semiconductor material, usually with at least 3 terminals: collector, base, and emitter, for connecting to an external circuit. Transistor is the most commonly used as either electronic switches in digital circuits like cameras or as an amplifier. Scan the quick response code to learn more on how transistor works, the different types of transistor, electronic circuit basics, and how to build a transistor circuit. That concludes our 3rd unit, and see you in the next chapter of this MOOC. Again, I'm Sir Jermil R. Aquiles, your TLE buddy. Thank you.